GeoNode from my network just by typing in geometry. And I'll home zoom to fit by pressing space H, home selected. Inside of our geometry that we just created, you'll always see a file node, and that's Houdini's way of bringing in external geometry, right? So if I wanted to bring in a, let's say a 3D scan, and of course pressing space H again because it came in really small, and he's twisted the wrong way as well, but here we have a 3D scan that I've just brought in for the file nodes. That's basically what that does. Moving on, we can also bring in alembics, and this is an example I found in the Houdini installation. This is just a bear running, and you'll see when we play it, oh, he's actually run off the screen. Where did he go? So to refresh it, you have to go back to the start, which is control and up arrow. And you'll see it's playing really, really fast. That's because we need to check real time down here, which will play it back in real time. Then I can also make the global frame duration shorter, say 80. And now we've got our bear running. We can do things like change how it's displayed to a point cloud or a bounding box. That can be useful for working faster in your scene. We can choose what attributes to import from our alembic. If I middle mouse click over the alembic, you'll see that there's actually not any attributes coming in, so I can't really make use of that here in this example, but just so you know it's there. And you'll see we've also got add path attribute ticked, which means we're adding that path. Well, now I've got rid of it, but yeah, we've got our path to where we loaded it from. Yeah, there's heaps more things you can do with this alembic, but to be honest, I haven't played around with it that much. I've only used it for basic things, just like this. So I'm going to leave that for you to explore more. So that's the alembic and the file node. We're nearing the end of our list here. I hope this has been useful for you so far, just expanding your node vocabulary a little bit. Of course, for anything that piques your interest, you can always read the help file for it by right-clicking on a node and going to help. That's not what I meant to do. Right-click on the node and go into help, which will bring up the help for that node. And you can read a short description of what it does. Next, we're going to have a look at groups, which, like I hinted at before, is one of the key things that makes Houdini work as it does in its procedural nature. Again, we're going to have a really quick basic example of groups and how you might use it practically. We've got a sphere in its own little object, our trusty sphere. It's always there for us. To show you what groups do, we've got our friend here, the torus. We can select some points like we did before by pressing 2, selecting some points, coming up to the toolbar and going to model, clicking on group, which will append a group node in our network view. Or another way we can do that is by selecting some points, typing tab in the viewport and clicking group, and that'll automatically put our point selection into a group node here. I'm just going to delete that. That's the default thing I have with that node, which I won't go to now. So, but we do need to give our group a name, so we'll call it test group. And if I middle click over on the node, oh, we get a warning. Test group is not a valid name for a group, which is a good point because we need no spaces in our group names. Okay, so we use an underscore instead. Now we can see that there is a point group here called test group. It has 22 points in it, and that's really good to know. And we can do some cool things with that group. So say we wanted to do our copy to points. Whoa, let's try that again. Say we wanted to copy to points. Copy our spheres to our points. Again, we need to make the spheres smaller because they're way too big. Make them tiny spheres. or we can make our torus bigger. So we're copying, like we did before, the spheres to the points of the torus, but this time we only want to copy onto our group. So we can do that. Another thing we can do with the group node is if we disable our base group, which is, you'll notice, a very defined way of selecting points, very specific. It's not very procedural. It's the buzzword of the day, isn't it? Procedural. Instead, we can group by the normals again, like we did with the delete node. That's what I'm trying to say. We'll say group only the nodes that are facing up in the y direction, in the y-axis, by this specific spread angle. We can animate that. Of course, you can animate any parameter in Houdini that you want, or we can do it along only the z-axis. So now you'll see we've got some nodes on the inside of our torus there. I'm just going to, again, append a null so we get rid of the annoying blue geometry there. So that's pretty cool. I'll explain what include by edges does in a second. And just like the delete node, we can include by bounding box, which again, you can animate. And another cool thing you should know with this keep in bounding regions is that you can actually use any geometry as your bounding regions. So say I come back to my torus and I want to use, I don't know, let's grab our teapot from before, okay? My teapot, I only want to select points within the radius of the teapot. I'll rename this teapot. Like, you'll notice that the group actually has a second input here, and that is the bounding object. So I can pipe in any bounding object to that, and you'll notice that it's only grouping points within the bounding volume. Oh, we also have to select the bounding volume, which is our teapot. Sorry, not bounding volume, bounding object. So now we've got our teapot, and it's moving across there. So if we wanted to animate this, I'll show you real quickly. We can alt-click in any parameter, set a keyframe, move down the timeline, drag it across, say to somewhere about there, alt-click again to set another keyframe, and if we play that through, now we've got a teapot coming through. We'll just fix that keyframe and also make this a little bit tighter. That's some amazing MoGraph action right there. Now that's all well and good, right? But what if I wanted to, instead of using a teapot, let's say I wanted to use, actually let's not use a platonic because we just used that. Say I wanted to use a sphere, not a sphere, a tube. But I wanted to keep the same animation that I made in my teapot. Well, that's not the easiest thing to do, but I could, for example, copy this, oops, I accidentally set a keyframe. I could copy this parameter by right-clicking on it, going to the x-axis of my tube, pasting a relative reference, which is linking those two parameters together, and then pipe that in. And you'll see that it's the same thing as before. However, that's an easier way to do that. If I instead had a transform node, pipe my teapot back in, and I'm going to delete this channel by right clicking and going to delete channels. Now if I instead did that animation in this transform node, by alt clicking in that parameter, coming forward towards the end, dragging it across, alt clicking again, now we have a similar animation as before, right? But since we have our animation stored in a transform node, we can then pipe any geometry we want into that transform node. So it's a really easy way of changing things down the track and keeping things more alive, more procedural. And what the transform is doing is it's storing all the PSR, position, scale, rotation, storing the position, scale, rotation values on our geometry itself. It's often more useful to store it on a transform node because then you can change any other geometry and have it easily have the same transform. Transform also has some other really cool options. So say if I wanted to rotate my tube before it goes through. And by the way, I remember from the first tutorial that I can see the tube because I've got its wireframe mode selected. Well, that's actually the original tube before it's animated. So I'd need this one, the transform. So it has pre-transform. We also have the pivot of our transform, which you're probably familiar with from other applications, but I'll just quickly explain that as well. Let's zoom in on this guy. I need to bring up my node handle. You'll see that the pivot is actually over here, so I can just drag that around, and if I rotate it, it's rotating from that pivot point. But if I moved the pivot across and then rotated it, you see it's rotating around here, okay? Okay, we've covered a lot there, groups and transform. This is only the basics of what you can do with groups in Houdini. They're really powerful, so I encourage you to play with them yourself, and we'll be covering it more in the future tutorials as well. So that is the group node. Did we cover the merge node? I can't remember if we just covered that. I'll cover that again. And we also covered the transform. Great. Moving on, we've got add, merge, and object merge. We'll cover them all now. And what the add node does in its simplest form, if I pop that down, turn it on its display, is it can generate a point at the location that you choose. So here it's generating at world 0. Another really useful thing that it can do is, if we go back to our sphere for a second, you'll see that in the primitive type there's no option to select only points like there is for the box in the grid, right? If I wanted to only keep the points of our sphere and not any of the polygons, what I could do is append it and add, and in the polygons we can go delete geometry but keep the points, and now we only have the points for our sphere. Then we can also generate new polygons by coming to the polygons tab, generating them by group. And you'll notice that it's the default option is all points. So it's connecting all of the points by their point number order. So if we try and find the first point is right here, then it's actually going down here, then going back to the second, and then going around. So that's just the way that the points are ordered. You can actually change that. This is a bonus node, all right, with a sort node. And say if we sorted it by the y-axis, we'll see that our 0th point, our beginning point, is at the bottom, and it's going around in a steady circle like that, which could be cool. Let's not overcomplicate things, with more nodes. So we've got, but we can also connect every other point. So we can say groups of 7 points. And like I hinted at earlier, groups are really powerful. So we can actually connect things by groups. If we had our, say we group by the bounding volume, call this group test, bounding regions, so we only select those middle guys. We can only connect those test group. And again, that can be animated here. Some sort of scan effect. And also particles, which we won't go into now. And then the other option is grouping by pattern. So similar to how we group the individual points, we can say we want to connect the first to the 150th point, and it'll do that. And I believe there's things you can, if you go into the help docs here and search by pattern, we can easily see some other examples of how we might add lines in between our points. That's about it for the add node. Okay, to explain the merge and the object merge, let's say we have our box and a sphere here. What I can do is press tab, type in merge, grab both of these and drag them into the merge node. And what the merge will do is it'll treat all the incoming connections or all the incoming geometry as one node. So now if I append a transform to that, we can transform them as one, or rotate them as one. Let's say also I had some other geometry I wanted to bring in. Let's say I've got a grid. You see it's actually created a grid object for us. But when I go inside here, assuming we have hide other objects on, you'll see that we don't actually have our grid object at all. So if I wanted to bring that in, the way to do that is with an object merge. And we click this icon here, the one with the little black pointer on it, and we can scroll to our grid object. And let's say we just wanted to bring the whole grid object in. And then we click accept, wire that into the merge, and now that's all being treated as one object. So in our object merge, let's say we only wanted to bring in the grid, right? Say there was other geometry in there. Maybe there was also like a sphere in a box, and we didn't want to bring those things in. We just wanted the grid. So we've only selected the grid to merge that in. But then what if I wanted to change that to bring in the sphere instead? I could, of course, come back to our object merge, go into the grid object, select the sphere, and bring that in. Another option would be to bring in the top level geometry node, and that'll bring in whatever is displayed. So if I display the sphere, it'll be merging in the sphere. If I display the grid, it'll be merging in the grid. But sometimes you might forget you might leave the wrong node displayed, or you forget about it and it brings in the wrong node, the wrong node. So one way to get around that is to append a null, and instead of referencing a specific object in our object merge, we can reference the null, which is like a placeholder. So you'll see we're not actually merging anything into our geometry right now. Then if I connect the null, sorry, if I connect the grid, you'll see because the grid is connected to the null and we're object merging in the null, the grid is now in there. And then I can simply change this over to sphere and box, and it doesn't matter which one I have displayed in here. Another thing I want to show you with the merge, this is a really cool trick that I don't see many people use, and I only found out about it recently. So if you select both nodes that you want to merge, and you Alt drag out from one of their outputs, it'll actually connect them together. And you release and it creates a merge. So again, you select both nodes, Alt drag out from an output, and it'll automatically create a merge with both of those connected, and with the display flag set to merge, which is a really neat trick. So to quickly cover the object merge as well, the object merge is a quick way of bringing in geometry from other places in Houdini. So say we've got our, say we've got another geometry node, and inside it, it's got an alembic from before. So I'm grabbing my bear example. Okay. And say I wanted to bring that into our network as well. What I could do is in the object merge, click this little icon here, which is like our browser button, come to our geo, click accept. Now we actually have our bear inside here. And then we can connect that up to the object merge as well. And then, like before, we can append a transform and rotate the whole world on its axis if we wanted to. One thing I did quickly want to mention as well, because this can be a little bit confusing when you start out, is that each geometry node has its own set of position, scale, rotation. So there's our, maybe I'll turn on the grid for this might help. So we've got our world, and this is like the top level transform, right? If you're coming from Cinema 4D, the easiest way to explain this is like thinking of this top level container as the container null of your hierarchy, okay? So it's the top level null that contains the high level transforms that everything else gets affected by. So we can shrink down null scene or anything like that. And then everything inside of this node gets affected by that. One of the little gotchas in the object merge is this button here, into specified object. You can specify a transform object to merge into, but normally what I do, and I think the intuitive way, is selecting into this object. So that'll merge it into this node like you would expect. And you can actually, if you want, you can save that as a default by right-clicking on the parameter and coming down to, where is it? Make current value default, and that'll save it. So anytime you open the object merge node, it'll bring it in with that parameter. That's the object merge. All right, we're on the home stretch now. All we've got left is the null, the attribute VOP, and the switch. So the null in Houdini is really easy. It's kind of like a null in any other 3D program. So from Cinema 4D, it's a similar sort of thing. It's just a placeholder. Except this one doesn't have any transforms in itself. And the way that I think of it in Houdini is kind of like a waypoint. So one of the most common ones you'll see in other tutorials is they'll name it something like out geometry to signal that it is the end of the geometry network. And the reason that that is a thing, that's a convention, is I'll quickly show you. Let's say we're merging it in like from before, right? If I go to merge in this out geometry, you'll see that it's at the top of the list, and that's because it's in all capitals. So that could be any text. It could be ants, and it'll be at the top. It could be ZZZ, and it'll be at the top because it's in all caps. So that's why you'll often see people name their nulls, their waypoints, with all caps to start with, because it's easy to find in this list, in these sorts of lists. Now, what I mean by you can think of nulls as waypoints is let's take a bigger example here, right? So this is another project I'm working on, and you can see that the networks can get quite large sometimes. So you can use things like colors and your naming to try and keep yourself organized, and usually use nulls at the start and endpoints, or at specific points that you want to remember to help you find that location in the network easier. So you can see right here I have my out null, so I can easily find that later on, and it's at the end of a large network. That's all I want you to see from this example, is that it's used to help organize things. The same goes for in, and there's different how do you say, there's different conventions that go with this. So you can create your own conventions where you color certain nodes this color, or I'll leave that to you. That becomes, it's not very important when you start out, as you're only just learning what things do, but as you start building bigger networks, they become becomes much more important to stay organized. So that's the null. The switch is a fairly easy one. If I append a switch, just like an object merge, connect them both up. What the switch does is it allows you to switch between the different inputs. And I want you to notice here in the network view, see how this one here, this wire or this noodle, is a solid one, whereas this one is dotted out. That's because this one is the active noodle. So if I select the first input, or in English the second input, this is in, of course, programming speak, so you always start with the 0th input, that would switch between the box and the sphere. That's fairly simple. And you can rearrange the inputs as well. And of course you can control this with absolutely any other parameter or attribute that you could think of with expressions, but we won't get into that right now. For now, that's a switch. Finally, the last note to cover really quickly here is the attribute VOP. Left this to last because it is like the wrangle and I guess the groups and the attributes. It could be a whole video in its own, so we're only going to touch the surface here. One of the things I love using VOPs for is any sort of noise, if we're working with noise. So if I wanted to distort this sphere with some noise, I could come into the VOP, type in noise. There's a bazillion different noises, but we'll take a NC alias, an AA noise. And the way this works is you wire different things together, just like up in the SOPs or the geometry view, except this in the VOPs, it's going horizontal from left to right. The way this works is we connect similar parameters to each other. So I want to take the incoming position of, I should have mentioned, just like the wrangle, we can iterate over different types of geometry. So in this example, we're going to run over the points. Then we can add that back to the original position. And then finally, I do that again. I put the result into the position. So we can generate a 3D noise, which is probably what we want in this example. And you can see we're deforming our sphere. And this is like the simplest example. Normally you wouldn't modify the noise from inside the VOP. What you want to do is click on each of these parameters and promote them. So we'll just take a couple of those. And what that does is it promotes them to the top level of the VOP. And then you can control it from here. And you'll see that it's much more faster and interactive in the viewport. And you can change all the parameters that you want from there. One of the neat little tricks for VOPs that I like is you can right click on, say, a noise. Say we wanted to promote all the parameters of the noise to the top level. We can right click on the noise, come to vex/VOP options and go down to create input parameters. And that'll automatically promote each one of these to the top level. So we can modify them easily here. And you can also click on each one of these and rename them to anything you want. So if I rename that to some gibberish, you can see it's changed the value there. That's like one of the simplest examples I can think of for the VOPs. Again, you can do heaps more complicated things, and you'll see that in other tutorials. Yeah, that's the basics of what the VOP does. So that's about it for the most commonly used nodes in Houdini. I hope that's been helpful to you. And again, these are the basics of each of these nodes. You can read about them more in the help documents, and I encourage you to play with them yourself and find out what they do. I hope I didn't lose you in the ant analogy. We'll see if that works at all. I think it's a useful way of thinking about how the points and the attributes work, and of course the groups and the wrangles could be tutorials in their own, and I've shown you the simplest case for them.